Inequalities and their graphs. Objectives: to write, graph, and identify solutions of inequalities. What is an inequality that represents the verbal expression? All real numbers p greater than or equal to 1.5. Okay, so we have p is greater than or equal to, so that means greater than or equal to, so it's eating the larger number. Remember, this is greater than, demented Pac-Man, there we go, is greater than or equal to 1.5. Okay, the next one says the sum of t and 7. So first, sum tells me I'm going to add, so I'm going to take t plus 7, is less than, so I'm going to use the less than sign. Notice it kind of makes that L, negative 3. Okay, a solution of an inequality is any number that makes the inequality true. Consider the numbers -1, 0, 1, and 3. Which are solutions for 13 minus 7y is less than or equal to 6? Okay, so we're going to start off. They're assuming that you do not know how to solve an inequality. So they're going to have you start off by just plugging the numbers in. So you'd have 13 minus 7 times -1 is less than or equal to 6. And so you'd have 13 plus 7 is less than or equal to 6. So you have 21 is less than or equal to 6. That one didn't work because that's not true. Okay, the next one, we try 0. So now I have 13 minus 7 times 0 is less than or equal to 6. So now I have 13 minus 0 is less than or equal to 6. So I have 13 is less than or equal to 6. That one's also false because 13 is larger than 6. Okay, then we're going to try 1. So now I have 13 minus 7 times 1 is less than or equal to 6. 13 minus 7 times 1 is 7. It's less than or equal to 6. 13 minus 7 is 6. So I have 6 is greater than or less than or equal to 6. So that one's true. And last but not least, I'm going to try 3. So now I have 13 minus 7 times 3 is less than or equal to 6. So I have 13 minus 21 is less than or equal to 6. And that's going to give me -8 is less than or equal to 6. That one's also true. So the only two that work are 1 and 3. Now, as we move through this chapter, you're not going to have to go through that process of working out every possibility. We're going to teach you how to solve it. Okay, it says, what is the graph of each inequality? So I have x is greater than -4. Now, when you graph this for me, we have 0, -4, and let's say -5. I don't need a precise graph, but I do need numbers on both sides of the number that we're looking at. Since we're looking at -4, I want numbers on each side, on the right and the left. Now, we have greater than, but we don't have the equal. So since it's just greater than, we're going to have an open circle. And now I have to decide which side of the line to graph on. Now, some of you may have heard, oh, the arrow, it's pointing this way, I need to shade this way. Well, that's true only when your variable is in the front. Otherwise, you can plug in numbers and say, okay, is 0 greater than -4? Would I rather have no money as opposed to owing someone money? Well, that's true, and so that's how you know which way you need to shade. Okay, the next one, C is less than 0, so I have 0. I'm going to put 1 and -1. Notice it's not equal to 0, so I'm going to do an open circle. And it says that it's less than 0, so numbers that are less than 0 are my negative numbers. Okay, and then last but not least, let's see, I have 3. I'm going to put 0. I'm going to put 5. Doesn't matter. Now this one says 3 is less than or equal to n, so I'm going to put a closed circle at 3 because it equals 3. And now I have to decide. Now notice on this one, the variable is not in the front, so we can't go in the way that the arrow is pointing, because if we try this, I would have 3 is less than or equal to 0. it should be eating the larger number, and 0 is not greater than 3, so I know I need to shade in that direction. If I could rewrite this, and you can, I could say n is greater than or equal to 3. Notice it's still eating the n. Then I could use that little arrow trick to say, oh, I'm shading in the direction of the arrow. Example 4, it says, what inequality represents each graph? Okay, so on this one, first we have to decide, is it open or closed? On A, it is open. So I'm going to have for A, I'm going to have an open circle. I have -3. Now notice it's getting smaller, so that means I know I'm going to have I'm not going to have the equal to because it's not shaded. It's getting smaller, so that means I have the less than, because it's all the numbers less than -3. On B, we start off at 0, so I have x and I have my 0. It's shaded right here, so I know I'm going to have an equal to. And notice it's going towards the 1, 2, 3, 4, so it's greater than 0. And you can use your little arrow trick on this one, because as long as you're putting the variable first, notice the graph is pointing in this direction, the arrow is pointing in this direction, and it's because I put the variable first. Example 5 says, what inequality describes each situation? Be sure to define a variable. Okay, so we're going to let h equal your height, because it says you must be at least 4 feet tall to ride the ride. So on this one, my height, if I'm 4 feet tall, can I ride the ride? When it says you must be at least 4 feet tall. Well, yes, so that means my height has to be greater than or equal to 4. Height, and we probably should say in feet. Okay, on the next one, on B, this says the speed limit is 35 miles per hour. So we can say speed, S will be our speed, so equals speed in miles per hour. So on this one, I know I'm talking about my speed. I know I'm going to have the number 35. Can you drive faster than 35 miles per hour without getting a speeding ticket? Well, no. So that means that our speed has to be less than. Would I get a speeding ticket if I'm driving 35? No. So it could also equal 35. Lesson check. Make sure that you've tried these before you come to class.